Good morning, I'm Lasa Sudishna and today I'm here to represent Strassen's matrix multiplication. Here is the introduction. The standard matrix multiplication algorithm multiplies two n into n matrices in the time complexity of order of n cube by performing n scalar multiplications. As the matrix size grows, the standard method becomes computationally expensive. In 1969, Volker Strassen proposed a fast algorithm that reduces the number of multiplications needed for matrix multiplication. Strassen's algorithm uses a divide and conquer technique with the time complexity of order of 2 to the power n to the power 2.81 time. Here it is significantly more efficient for larger matrices and is a foundational concept in fast matrix multiplication algorithms. Here is the differences where of the traditional versus Strassen. The time complexity is order of n cube and here the time complexity is order of n to the power 2.81. Here it is the direct multiplication of matrix element, that is we use divide and conquer, and the number of matrix multiplication 2 by 2 are 8, and here for Strassen it is 7, and it is best used for small matrices. In traditional it is used for large matrices, and it is if the implementation is simple for traditional and more complex due to recursive nature and Strassen. And the next, what is Strassen's multiplication? It is basically based on divide and conquer technique, and here we are given A and B matrices, dividing for n by 2 submatrices. Now here the instead of 8 multiplications like the traditional method, the Strassen cleverly computes only 7 matrix products, that is P1 to P7. Here are the formulas that uses the combination of additions and subtractions. Here they are given P1, P2, P3, P4, P5, P6, P7. You have to note it down. And next, these 7 products are then used to compute the final result matrix, that is C is equals to C11, C21, C21 and C22. Here then you have to substitute all these P1, P2, P3, P4, P5 until P7. You have to substitute in C1 and C22, C12, C21 and C22. And next, let's take an example for a proper understanding. And here is the example. A is A1, 2, 3, 4 and B is 5, 6, 7, 8. Let us now write it properly to understand. A11 is equals to 1 and A21 is equals to 2, A21 is equals to 3 and A22 is equals to 4, vice versa for B also. And now we have to calculate P1, P2, P3, P4, P5. Now after calculating, we have got P1 is equals to minus 2, P2 is equals to 24 and P3 35, P4 8, P5 65 and P6 minus 30 and P7 is minus 22. Now let's see what is the final result. Now C11, we have to substitute all these P1, P2, P3, P4, P5 in these matrices. Now you can see P5 plus P4 minus P2 plus P6 is equals to, we have substituted all these P1 to P7 matrices in these C11, C12, C21 and C22, and the result you will get is A cross B is equals to C, and the overall result you have to write it here, and this is your given and this is the answer for your given question. And if you wanted to check it is correct or not, you have to first do it in traditional matrices and then you can check in Strassen's matrix multiplication. And the advantages of this Strassen's matrix multiplication is it is faster for large matrices, and the disadvantages is it is overhead for small matrices, more complex implementation, and the applications are computer graphics, scientific computing, and parallel computing. Thank you.